Okay, hi. So today I'm going to present about the experiment 5 that we did and regarding the measurement of the jet force. So in my group, so we are in group 11, and for the group 11 members, so we have myself, Zafran bin Zainal, and then one is Fadhlillah binti Azmi, Theaveraj Ravi, Zulfaiqah Iyana binti Zulkarnain, and Muhammad Mustaqin bin Muhammad Roslan. Okay, so I'll proceed with the report summary. So in this experiment was conducted to identify the reaction force produced with the change of momentum by the water fluid strikes between the flat plate and the hemispherical surface, as well as comparing the theoretical force value with the experimental force value using the momentum equation. The momentum force is determined by measurement of the force produced by the time the water fluid strikes the surface, according to Newton's second law of motion, which then deflects the jet at various different angles. In this experiment, several aspects are considered, which the measured momentum force, volume of water collected, which is constant at 2 liters, time taken, flow rate, which is the QX, velocity of the water jet, theoretical momentum force, and lastly, the percentage of the relative area between both surface flat plate and also as well as the hemispherical plate. For the measured momentum force, where is applied to exert the force, is assumed to be the force of the water strike of the surface. So that's all from me. I will pass to the next person. Thank you.
So now I will explain the theoretical background for this experiment. So according to the Newton's second law of motion, due to the change of momentum of the fluid, the jet of fluid will generate a force when impinging upon the flat surface or upon a flat plate or hemispherical surface. For example, when a velocity of water V from a jet nozzle with diameter D strike on the flat plate or a hemispherical surface, the rate of change of momentum m equal to rho av produced, and its magnitude is the same as the force exerted on the surface of the plate or the hemispherical surface to support the water jet. By depending on the surface, the F generated by the jet of fluid when it strikes differs. Both pictures on the slide depict a jet of fluid issued from the nozzle of diameter d moving vertically upward with a velocity v1 and strike a flat plate and the hemispherical plate surface respectively. The jet is deflected by the surface of the flat plate and the hemispherical surface through an angle theta and leave the surface with a velocity v2. Okay, to find the theoretical force generated for the flip plate when a jet of fluid strike is by using the equation on the right side of the slide, which is F equal to rho AP1 squared minus rho AV2 squared cos theta. Since since theta equal to 90 degree, thus the V2 cos 90 degree is equal to V2 equal to 0. So the equation can be simplified to F equal to rho AV1 squared. And to find the theoretical force generated when a jet of fluid strikes the hemispherical surface is by using the equation on the left side, which is F equal to rho AV1 squared minus rho AV2 squared cos theta. Since theta is equal to 180 degree, V2 cos 180 degree equal to negative V1. Thus, V2 equal to negative V1. Uh, so the equation could also be written as F equal to rho AV1 squared, where the expressions are F equal to theoretical force exerted on the flat plate or hemispherical surface, Newton, A equal to the cross-sectional area of the nozzle, m squared, rho equal to density of water, kgm cube, theta equal to angle of water flow after impact on the flat plate or the hemispherical surface, degree. V1 equal to velocity of the water jet before the impact on the flat plate, or the hemispherical surface, and V2 equal to the velocity of water jet after the impact on the flat plate and the hemispherical surface. So that's all from me. I will now pass to the next person to explain.
Hello there. I'm here to explain the experimental procedure of our experiment. There are 8 procedures. The first one is tested deflector, which is the flat plate is assembled. The second one is pointer to zero, which is 0 notch, is set by adjusting the screw at level mechanism. When doing so, do not place any weight on the level mechanism. The third one is main switch and the pump are turned on. The fourth one is the flow control valve is opened slowly and put the desired weight, for instance 1 Newton, on the level mechanism. Flow control valve is adjusted until the pointer at level mechanism is at 0 notch. The fifth one is sliding valve is closed. Flow rate of water is determined by recording the time required to fill up 3 liter volume of water in volumetric measuring tank. The sixth one is sliding valve is open. Step 4 and 5 is repeated by increasing the desired weight on the level mechanism until the flow control valve is at maximum opening. The seventh one is main switch and the pump is turned off. Sliding valve is open and the flow control valve is closed. The last one is weight on the level mechanism is removed and deflector, which is a flat plate to hemisphere surface, is changed. And step 2 to 7 is repeated. Thank you.
Now I will explain about analysis and the raw data. In the slide shown, table 5.1 and 5.2 for the flat plate and the hemispherical surface respectively for both of the data. So, for measure of the force, we shown on the table for both of the data got from this experiment. Volume of the water collected are constant for all of the data in 2 liter, and time of this experiment are got it. By using of formula Q equal to V over T, we got the value Q for both of the data. After that, using formula of velocity, we got the value of velocity for all of the data for both data. So finally, to get the comparison between the measure and the theoretical force, using formula for percentage of relative value, and we can get the difference for between for both of the data for percentage of relative error. So I will pass to next person for the result and discussion.
Okay, now I will explain about the results and discussion. So for result, as you all can see that we obtained two results from this experiment, which is the first one is table 1, result for flat plate, while table 2 is result for hemispherical plate. So from this experiment, we can obtain the value of FMEA, volume of water collected, and time taken. For value of Q, velocity, F theory, and percentage of relative error, we need to calculate it using formula. So in order to calculate the Q value, we can use the formula of Q equal to V over T, where V is the volume in liter and T is time in second. Since the value of density and the diameter of nozzle D is already given in this experiment, which is 1000 kilogram per meter cube and 10 mm respectively, we can obtain the value of area of nozzle by using the formula of pi d squared over 4, where the diameter is in meter unit. Thus, the value of velocity can get by using the formula of V equal to Q over A, by using the Q value that we calculate just now and the area of nozzle that we also calculate just now. For Q, velocity and area for both flat plate and hemispherical surface, we can use the same formula. But however, to get the force theory or FTH, we need to use different formula for flat plate and hemispherical surface, which is for flat plate, we use the formula from equation 2, which is F theory equal to density times A times V squared. While for hemispherical surface, we calculate it by using the equation 4, which is F theory equal to 2 times density times area times V squared. Meanwhile, to obtain the percentage of relative error, we can just using the given formula in the data, which is FMEA minus F theory over F theory times 100. So I will start the discussion with the first question, which is to plot a graph of log FMEA versus log V, for both flat plate and hemispherical surface. So since we already obtained all the data, including the FMEA and velocity and also the F theory, we can just insert the value into the calculator and then we can plot the graph until we get the graph like in figure 1 and figure 2. So I'll proceed with the first question, which is to estimate the slope of the graph for both flat plate and hemispherical surface and compare with the theoretical value. From the graph just now, we clearly can see that the value of force and velocity can affect the steepness of the graph. We know that the equation of linear graph is y equal to mx plus c, where m is the gradient of the slope and c is the y-intercept. So from the graph just now, we can obtain the value of linear equation of each for each graph, which is for flat plate, we can get the y equal to 0.5731x plus 0.5384 and y equal to 0.5008x plus 0.5522. While for hemispherical surface, we can obtain the linear equation, which is y equal to 0.5405x plus 0.3718 and y equal to 0.4994x plus 0.4025. Okay, so from this equation, we can compare the difference between the value of slope, which is the m value for both flat plate and hemispherical surface. So for flat plate, the value of slope for FMEA versus velocity is 0.5731, while for F theory versus velocity is 0.5008. While for hemispherical surface, the value of slope for FMEA versus velocity is 0.5405, while for F theory versus velocity is 0.4994. So there is a difference of the slope between F measured value and F theoretical value, but it is not too big, so it is acceptable. The difference in the value between the measured value and theory value is due to the errors during the experiment. For the next question is to estimate the slope of the graph for both flat plate and hemispherical surface and compare it with the theoretical value. So from the graph that I showed just now, we can clearly see that the value of force F and velocity V can affect the steepness of the graph. So we know that the equation of linear graph is y equal to mx plus c, where m is the gradient of the slope and c is the value of y-intercept. So from the graph, we obtain that the linear equation for flat plate is y equal to 0.5731x and 0.5384 and y equal to 5008x and 0.5522. While for hemispherical surface is y equal to 0.5405x plus 0.3718 and y equal to 0.4994x plus 0.4025. So from this value, we can compare the difference between the value of slope for graph of FMEA versus F theory for both flat plate and hemispherical surface, as we know that the value of slope is equal to m, which is the gradient. So for the flat plate, the value of slope for FMEA versus velocity is 0.5711, 0.5731, while for F theory versus velocity is 0.5008. While for the hemispherical surface, the value of slope for FMEA versus velocity is 0.5405, while for F theory is 0.4994. So the difference of this slope between F measured and F theoretical is not too big, so it is acceptable. And the difference in between the measured value and theory value happened because maybe due to the error during the experiment. So the next question is to estimate the y-intercept of the hemispherical surface to the flat plate and compare it with the theoretical value. So from the graph 1 and graph 2, we obtained that the linear equation is equal to y equal to mx plus c. And for both flat plate and hemispherical surface, where the y-intercept can be obtained from the C value. So we know that the y-intercept of the hemispherical surface is 0.3718 and y-intercept for flat plate is equal to 0.5384. So the ratio of y-intercept of hemispherical surface to the flat plate can be calculated by dividing the y-intercept of hemispherical and y-intercept for flat plate. Hence, the ratio of y-intercept of hemispherical surface to the flat plate is 0.6906. While from the equation 2 and equation 4, we can obtain the theoretical ratio for the y-intercept of hemispherical surface and flat plate by using the formula of log 2 times density times A times V over log density times A. So we can obtain the y-intercept ratio of hemispherical surface to the flat plate is 0.7276 for the theoretical value. So from these values, we can see that the difference between the y-intercept between the graph and y-intercept from the calculated value from the formula. So this has happened due to the errors while doing the experiment, such as parallax error or systematic error. Okay, I will proceed with the next question, which is to compare the force exerted on the hemispherical surface with the one on the flat plate. Which one is greater and why? So from the data obtained in table 1 for flat plate and table 2 for hemispherical surface, we can see the force exerted on hemispherical surface is greater than the flat plate. This is because the change in momentum of the hemispherical surface is bigger than the change in the momentum of the flat plate. When the water jet from the nozzle hit the hemispherical surface with 180 degree angle of the surface, higher energy is produced, which enable the water to reverse its direction. So due to the high impact of velocity resulting to the increasing in the momentum and total energy exerted, and then the time taken also becomes shorter. So but for the flat surface with 90 degree angle, water can only flow in one direction. So lower energy is produced when water hits the surface of the flat plate, and time taken also become longer. So for the next question is to compare the percentage of relative error for both flat plate and hemispherical surface as function of jet velocity. So at table 3 is the average percentage of relative error for flat plate and hemispherical surface. We obtain that the average of percentage error for hemispherical surface is lower than the flat plate. This may happen due to the different shape and angle for both surface. As we can see from equation 1 for flat plate and equation 3 for hemispherical surface, it involves the angle of plate to calculate the force, where different angle resulting to obtain different value of forces exerted on the plate. Thus, it will affect the velocity from the water to the plate, since from equation 1 and equation 3, we can see that the angle also involved in calculating the velocity. Other than that, it may also due to the systematic and parallax errors during the experiment. The shape of the coil also must be in the straight position, as it will also affect the inaccuracy of the velocity by the water. Now, briefly discuss on factors contributing to errors or inaccuracy in experimental data and the possible recommendation to improve the existing results. There are several factors that contributes to the error and inaccuracy in the experiment data. For the first one is parallax error, especially the position of eye level when taking the measurement or readings. The second one is the control valve is not fully open before adding the weights, which might affect the result and readings. This will also affect the velocity of the water, where it might be less than the actual value. The third one is error, where bubbles exist in the pump, also might happen, which result to the inaccuracy of the result obtained. So it is very important to make sure that the observer eye level is perpendicular to the calibration when taking the readings and measurements. Observer can repeat the reading to at least 3 times in order to get the accuracy of the result obtained. Then make sure that the control valve is fully open before proceed with the next step in the experiment. And last one is to make sure that the bubbles that may exist in the pump is removed before starting the experiment by opening the valve. The last one is to suggest 2 applications of jet impact in industry. So there are 2 applications of jet impact in industry, which are the first one is to generate electricity. So jet impact is used to rotate the turbine, which is the Pelton wind in the generator. So the water jet apply the forces tangential to the wheel, where it will create moment on the wheel to the maximum value, and thus will increase the mechanical energy of the wheel. The rotational energy produced is then being converted to mechanical energy. The second one is as a water cutter. It uses high pressure and high velocity to slice metals or other materials in the industry. Water jet cutting can create a smooth edge and does not produce dust or particles that can be harmful to humans.
Okay, hi everyone. So now I'm going to proceed with conclusion. So for conclusion, from the experiment, graph log F versus log V that has been plotted above, a straight line with a positive gradient has been obtained. The value of the log force is obtained from log rho AV, and then for flat plate, while for hemispherical surface is from log 2 rho AV2 with 2 as a gradient showing that a theoretical force that generated from the jet impact was proportional to the square of the velocity of water. So besides that, the theoretical force that generated was inversely proportional to the square of the diameter of the nozzles. So that the theoretical force for the flat plate and the hemispherical plate can be calculated by using the F theoretical equal to rho A V 2, and then force theoretical 2 equal to 2 rho AV2. The average theoretical force for the flat plate is 2.4 Newton, while the average theoretical force for hemispherical plate is 4.44 Newton. Therefore, we can conclude that the force exerted on the hemispherical plate is greater and almost double compared to the plate of the flat plate due to the momentum impact. The average percentage of the relative area for flat plate is higher than the hemispherical surface. The average percentage of the relative area for the plate is 19.87%, while the hemispherical surface is 11.46%. Thus, this occurs because there are some errors during the experiment and causing the result obtained to be might be inaccurate for a bit. So that's all from me, representing group 2. So that's all from us. Thank you.